Okay, this lesson we're talking about the behavior of the function at the zeros, at the x-intercepts. Now, we can find the x-intercepts at the zeros by looking at those in factored form. Whatever would make those little factors equal to 0, that's where my zeros are going to be. But what we're looking at here is what happens when we have an exponent on our fact. So if we have a bunch of factors, so far we haven't seen this, they've just been like this, but sometimes you could have like a little square on one of those factors. So that's what we're talking about in this. Here, I'm going to move that down so you can see. So our factors so far had just looked like factors, and we could find our zeros there, but it's possible that you could have a square or a cube on your factor. And how does that affect the behavior of the function at that x-intercept or at that zero? Now, the ones that we've looked at so far haven't had any exponents, i.e. the exponents are 1. Those are the normal ones. And we know that that means when we're sketching them, if there's a 0, it's just going to go straight through, or it might be coming down. But if your factor has no exponent or has exponent 1, which means no exponent, then it's just straight through. There's nothing weird happening. It's just going to go straight through the x-axis at those places, at those particular zeros that come from those factors. If you have an even exponent on your factor, that is going to affect your 0. You're going to get a turning point right on your x-intercept. So it could look like this. Or it could be going down. But the turning point is going to land right on the x-intercept from your factor. And the third thing that can happen is you can have, that's if you have an even degree, so that would be a 2 or a 4 or a 6. But you could have an odd exponent that's not 1. 1 is odd, but it just goes straight through. But a 3 or a 5 or a 7 or a 9 on your exponent on your factor, that's going to give you a squiggle on your, so if there's your 0 on your 0, that just means it's going to come up as if it's going to turn, but instead it's going to turn and go the other way. Similar to what would happen to x cubed at 0. So it's like, or it could go this way. But it's going to have a squiggle right on the x-intercept. So let's take a look. Let's move the sheet ahead a little bit here and examine this example. It says, oh, we have a polynomial function in factored form, and it says state the degree. That's easy. We've done that already. Leading coefficient. That's also easy. X-intercepts. Well, in factored form, that is easy. And then sketch. Okay, let's see if we can do that. So we'll start by finding the degree. Now, degree in factored form, we know how to do it, but isn't it not so easy? So we have, we'll start with this one. We take the highest power of x in each bracket and multiply it together with the numbers in the front and come up with the biggest term, and then look and find the degree and the leading coefficient. So in this one, it's the x. That's easy. And we have to remember to multiply it by 3. Now, we have to be careful here, though, because this is not just x. This is, whole bracket is going to be squared. So the highest power of x in this bracket, when I'm done squaring it, is not x. It's going to be x squared. Same thing here. When I cube this bracket, multiply it by itself 3 times, I'm going to take that x, I'm going to multiply it by itself 3 times. It's going to be x cubed is my highest power of x. And now I'm going to multiply all of these x's together with the 3. So I end up with, there's no coefficients with any of these x's. So it's just going to be 3x to the, now remember we add exponents when we're multiplying, so it'll be 5, and that's a 1, so it'll be 6. That's my leading term, if you want to call it that. So my degree, as the highest power of x, is going to end up being 6, and that's even, and my leading coefficient is the number in front, which is a positive 3. So it doesn't ask for my end behavior, but end behavior is going to be important for my graph. So I'm going to write my end behavior. The end behavior, if it's an even degree, so that means they're both going up or both going down, and the leading coefficient is positive, meaning they're both going up. So how do we write that? We say as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, it's also going up. So f of x is approaching positive infinity. Okay, so that's going to help us. Now we need the x-intercept. Well, those are easy because it's already in factored form. Let's find our x-intercepts, or another word for that is their zeros. We can just look at our different factors. What would make that equal to 0? We'd say, oh, x equals 1. What would make this bracket? Now the square is not going to change that. If this is 0, 0 squared is still 0. Be negative 2 and positive 4. Those are my x-intercepts. Now we're going to use that information to make a little sketch. So let's move the paper up just a little bit. And let's see what we got going on here. Okay, so I'm going to draw a little axis. And I'm going to put my zeros in. One is at 1, negative 2, and 4. 2, 3, 4. My end behavior is both are going up. So it's going up here and it's going up here. And we have some interesting behaviors. We have, I'm going to move down here. At this factor where the 0 is 4, it's a cubic. So this one is going to be a squiggle, isn't it? Because the exponent is a 3 on that factor. And the negative 2 is going to be a turning point. Now we don't know which direction it's turning, but we do know it's a turning point. And that one is just a regular straight through. So nothing exciting happening there at the 1. Okay. Let's see here. Now we know the end behavior is going to come up, and at that 4, it's going to have to be a squiggle. So that means it's got to go up this side. So it's going to squiggle this way, right? At the 1, it's just going straight through. So it's squiggling. It's going to have to turn around so that it can come straight up through there. Whoops, just made my dot a little bigger. And then it's going to turn around to come down to the 2. When it gets to the 2, it's going to have to turn around again. And we can see that that end behavior did work out. It did turn out to be what we wanted, right? Both going up like we suggested it would. So it's a squiggle there, a straight through, just a regular going through, and then a turn right there at the negative 2. And that's a pretty good estimation of what that graph would look like.